Uh, Hello everyone. So welcome to Codeforces Round 966, which was the Division 3 contest. And today we are going to see a few questions from that contest. And yeah, as promised, I will give a shout out to the top performers. That will be at the end of the video. Uh, so yeah, so let's start with the first question. So the first question is called the primary task. Uh, Primary task. So in this question, we are given a string. Which is a numeric string, and in that and in that we have to determine whether it is of the form 10 raised to x, so that x is greater than equal to 2. So all you need to check is that the length of the string is at least 3. The length of the string should be at least 3, and that we have to check, and we have to check that first two numbers are 1 and 0. The length of the string is at least 3, and the third thing is uh, the number after. So if our string is something 1001, so this isn't a valid string. It should be something like 1010, something like that. So the third digit should not be 0. Third digit should not be 0, and whatever the number is after the third digit should be greater than equal to 2. So these few conditions we have to check and print yes, else you will print no. Okay, this was the first question. Moving on to the second question, seating in a bus. So in this question, you are given an integer n, number of seats, and we are given a permutation p. So how is this question done? So what is happening in the question? So if we are given this permutation, for example 5 4 2 1 3, so we have a bus with n seats. So for in this case we have 5 seats, and initially all the seats are empty. So first person comes and can sit anywhere. So first person will come and sit at this place. Now the next person can sit only at the position if one of its neighbor is occupied. So 5 will come and sit here. Now 4 will come. Now 4 will come and sit next to 5. Now if 2 comes, 2 is sitting at a place whose neighbors aren't occupied, so it is not a valid sitting. We have to report that. So how do we go about solving this question? It is simple. We just maintain a boolean array of length n plus 2. So essentially we maintain a boolean array of length n plus 2 and initialize it to false initially, and whatever is the first digit of the permutation will mark that true. So for example, in the previous example that I took, 5 4 3 5 4 2 1 5 4 2 1 3 will mark this initially as true. And the only thing we now need to check is that if for a given number, if either of its neighbors are true, make it true, and if both the neighbors are false, we break it and say that it is not possible. That is all that we need to check. So that was question number 2. Moving on to the question number 3, numeric string template. So in this question, we are given a array of length n, which has some number. So for example, this I'll take the example test case 3 5 2 1 3, and we are given m many strings, which are alphabetical strings. So for example, one of the examples is 1 AF B ABF DA. Okay, this is the string that we are given. So we have to check whether these strings fall. So we have to check whether the strings are satisfying the template's condition if the length of the string should be equal to the length of the template that we are given, and there is one-on-one equivalence with the digits also. So what do I mean by that is, look at 35213. So A, B, F, D, A. Now A corresponds to 3. Through if A corresponds to 3, it will correspond to that throughout the string. So it cannot be like, if my string is like this and I have BB, this is not valid. This is essentially not valid. That if A is corresponding to 3 over here, then it should correspond to 3 throughout the string, not change to another letter. And similarly, we cannot have something like 1 and E, something like that. That if 1 is corresponding to 1 should correspond to same letter, and same letter should correspond, and same letter should correspond to the same string only, not to a different. Same letter should correspond to a same integer only. So we cannot have something like this, that we cannot have something like dd12, or we cannot have something like this, that uh, same letter is being correspond to two different string, two different number, or same number is being correspond to two different letter. This is not allowed. So how do we go on checking about this? So this is pretty simple. All we had to do, we had to maintain. What I did was, I maintained two dictionaries for each of the string. So what I kept on doing is, I maintained two dictionaries. So essentially, if dictionaries from conversation from string to array, string to template, string to number, and a number to string. So there are four cases that are possible. That once you so first of all, if the string length is not equal to n, we can straight up say no, that this is not a valid string. But if it has a length equal, so what we'll do, so I will take an example again, ABFDA, and our template is 35213. Okay, so we'll look at the digits. So we'll look at A and 3. So uh, in this dictionary, S2A, will our key will be a letter, and our value will be our key will be a letter, and value will be an integer. And on the other way around, in the other dictionary, our key will be an integer and it will be a letter. So the value will be a letter. So this is what we are going to do in this question. So initially, what are the possible cases that can occur? That is, both the letter and the number are not in the corresponding dictionary. Like A is not in the letter dictionary. If A is not in the letter dictionary, and the corresponding number is in the integer dictionary, then this is a invalid string. If A is in the letter dictionary, and the number is not, if A is not in the, so there are four cases possible: no, 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 yes, yes, no, yes, yes. So if neither the letter nor the number is in the letter dictionary, we add them to the respective dictionaries by giving them each other's key and value. So essentially, in this case, what we'll do, dictionary of letter to int, uh, a letter will have value 3, and the other way around will have value A, like the string. So this is what we are going to do in this case. But if in these two cases, we know that one is allocated and another is not allocated, in this case we can directly return no. And in the third case, if A is also allocated and 3 is also allocated, we should ensure that A is mapped to 3 and 3 is mapped to A, like they are mapped to each other. And only then we print S. If they are not mapped to each other, we'll print no. So we can straight up say it's an invalid string. So that is all we had to check in this question. Moving on to the next question. Right, left, wrong. So this was a slightly interesting question. So in this question, we are given an integer n. We are given an array of integers. So I'll take the example 3, 5, 1, 4, 3, 2, and we are given a string consisting of L and R. So L, R, L, 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 R. Okay. So what we have to do, we can do the following operations as many times, so as many times we want. So we pick a, so we pick a L and R. We pick a L, we pick a R, and what we are going to do is, we pick a L, we pick a R, and then we initially the score is 0, and we add all the score, and after we pick an L and R, we can add this entire score. We can add this entire score to our score. So in this case, the score will become 1 plus 2 plus whatever the total is, it will become 18 if I am correct. Yes, the score will become 18. But there is another example which is weird, not weird, but difficult. So look at this: 1, 2, 3, 4, 5, L R L R R. The last test case. So in this case, one can first pick this two L and R. We'll get the score as 7, and then we pick this L and R. So it will be additionally 15, and the total score will be 22. So how do we go about solving this question? So what we have to do is, so you can see that it will be wiser to choose, a smaller it will be wiser to choose a smaller, closer L and R first. Okay, but can we do something better? So what if we start, so we will use two pointer method over here. First of all, I will find the prefix sum of the array. So prefix sum is nothing but prefix sum of an array A. The ith element of prefix sum of array is summation of all elements from 0 to I for that array. So for this case, prefix sum will be 1 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 plus 5 is 15. Essentially sum of previous first I elements of that array. Okay, so now we'll use two pointer approach. So what we'll do, we'll have a two pointer approach, and whenever we come across L and R, what we'll do, so if at I is at some position and J is at some position, which are our 2 pointers, whenever we come across L and R, we increase our score by the sum between these two, that we can find out by doing a prefix sum of I minus prefix sum of J minus prefix sum of I minus 1. We can do this. Okay, what else can we do? So this is one case when the letter at I is L and R. What if both have L and L over here? So in that case, what we'll do, it might happen that there exists a L before there will exist an R before this. So in that case, we'll do I will be as it is, J will be decreased by 1. If we come across L and R, in that case we'll increase I by 1 and reduce J by minus 1, J by 1, and increase I by 1, decrease J by 1. If we come across L and L, we increase we keep I as it is, decrease J by 1. We come across R and R, then we increase I by 1 and keep J as it is. And if we ever come across R and L, then we increase I by 1 and decrease J by 1. Both will do. And what is the stopping condition? Stopping condition will be when occur when J will be less than I. That will be a stopping condition. So we follow this procedure, and whenever we get so after doing this, whatever score we get will be our answer. We'll have a quick dry run of this example. So look at this example: 1 2 3 4 5 L R L R R. Initially our I equals to 0 and J equals to 4. So we have L at I and R at J. So our score was initially 0. After the first iteration, our score will become 15, and I will become IJ. So I was initially 0 and J was initially 4. After this iteration, I will become 1 and J will become 3. So so our I comes over here, and J comes over here. Okay, now both are at R and R. In that case, we saw that if we are at R and R, we'll increase I by 1. So I will become 2, and R will remain as it is 3, and score will be as it is 15. Now you can see that there is, uh, in this case, there is L and R next to each other. Since there are L and R next to each other, we'll add their score to our score. So our score will become 22, and J will become 2, and I will become 3, and this is our stopping condition. So this is how we are going to solve the condition. We'll print 22 as the answer. So moving on to the fourth question, which is the uh, photo shoots for gorillas. So yeah. Okay, photo shoot for gorillas. In this question, we are given an n cross m grid. We are given an n cross m grid, an integer k, which is an integer k, w the number of gorillas, and a integer array, which is height of gorillas. Okay, so we are given this in the question. And what we have to do, we have to maximize the spectacle. So maximize the spectacle of the array by placing the gorillas into the grid, so that every grid has at most one gorilla. So what do you mean by spectacle? Suppose you have a 3. So suppose our n and m are 3 and 4, and k is 2. So spectacle and what is spectacle of an array? Spectacle of this grid is the spectacle of uh, all the spectacle of all the subgrids of k cross k size in this array, and spectacle of a k cross k grid is essentially sum of height of all the gorillas in the k cross k grid. Now the question is now the question is now the question is how do we uh, uh, here the question now is ki how do you uh, another question is how do we calculate this. So what we can do is now just for now just look at this. Okay, we can calculate that whether how many subgrids, k cross k subgrid, does a particular cell come into. So for example, this corner cells will only come in one k cross k subgrids. This cells will come in two k cross k subgrids. How? I'll show you. So okay, sorry, bad drawing. Okay, this should work. So so if you look at the one pointed to, so this particular cell will come in. This particular cell, which is mounted by blue, will come in these two subgrids. Okay, and similarly the center one will come in 4 k cross k subgrids. Now the question is how do you now the question is how do you find these values. We know that n cross m is less than equal to 2 into 10 raised to 5. So our approach will be, we find this we for every cell we find out how many subgrids they come into, and we'll sort that array. So for example, this above array when sorted will give us this, and we'll sort the heights of our gorillas also, and we will and what we'll do, we'll place the tallest gorilla in the cell which occurs in the maximum subarrays, like this, and our answer will be the product of this array, the sort of dot product till the size of the gorilla mini. So this dot product will be our answer. Dot product of these two vectors will be our answers. So how do we go about doing it? So now let's see how do we go about this. Uh, So now how do we calculate this value? So let's take an example. Let's take an example. Suppose our k is equal to 2. So we can see if our k is equal to 2, and look at this particular cell. Then if look at this particular cell, what we'll do, this is the first subarray, this is the first subgrid it will be a part of, and now let's just slide the subgrid down. So 1 2, if the k was 3 and if the grid was bigger, if the k was 3 and the grid was bigger, so let me draw a bigger rectangle. Okay, so this was the first subgrid it would be a part of, and if we keep sliding it down, so 1 2 3, so vertically it will be part of 3 subgrids, and if we do it horizontally it will be part of 1 2 3 subgrids. So it can be, so any, so what and since what so the total number of subgrids it will be a part of is number of vertical subgrids into number of multiplied by number of horizontal subgrids. So it will be a product, it will be a product of two numbers. Okay, it will be a product of two numbers. That is, I guess, understood by now. Now what we have to find out is, based on the position, we have to find out how many based on the position we have to find out how many vertical subgrids it can be part of and how many horizontal subgrids it can be part of. Suppose in the same example is k is equal to 4. So whatever that number is definitely upper bounded by k. It cannot be greater than k. Other number it could be is, so if suppose our I is equal to 1 over here, if we are using 0 indexing, and look at this, look at this guy. So it can only be part of at most two k cross k grids, for 2k cross k grids in this case. So for example, this one, and this one. So it is, so we also know that it is upper bounded by I plus 1. On the other hand, if we look at if we take our I down below here, I is equal to I guess it will be 4, not 4, I is equal to 3, and look at any look at this grid. So so this grid will also be part of so we need a 4 cross 4 grid, but this grid will also be part of let me change color. This grid will also be part of 1 and 2 subgrids. So this value is also bounded by n minus I, because n is 5, and there can occur another case. There can be another case that can occur. There can be another case where there can be another case for which we'll have n minus k plus 1 many subgrids. This is essentially the case where everything is quite constrained. So for example, if our n is equal to 3, m is equal to 4, and k is equal to 3, in this case, okay, sorry, I had to do k is equal to 3. In this case, the value at this point, the value of these two, k will be 3, these two number will be 2, but in this case we can only put one k cross k grid. So we need this guy also, that how many grids can actually fit into at most this many grids can be fit into this only n minus k plus 1 many grids can be fit into this place. So that is this thing. So for a given cell I comma j, the number of subarrays it can be part of is essentially minimum of k I plus 1, n minus I, and n minus k plus 1. This, and similarly for the other dimension, it will be minimum of k j plus 1 m minus j and m minus k plus 1. This is the answer. And essentially by doing this you will get this array, you will get this array. Then we sort both the arrays in reverse order and take the dot product essentially. And by doing this we'll get the final answer. So yeah, that was the question number 5, gorilla photo shoot of gorilla. And moving on to the next question. This next question is a bit special question because I couldn't solve it during the contest, but when I actually solved it, I realized something really important about this question. Let me get to the description of the question. Moving on to the question number F, color rows and columns. I couldn't solve this question during the contest, but there is something really important, really special about this problem, which I realized when I actually solved the problem. So I'll explain what is it at the end of the explanation of this problem. But yeah, so in this question, we are given n rectangles, uh, integer k, and the dimensions of n rectangles. Okay. So what is happening in this question? We can take a particular rectangle. We can take a particular rectangle, color its and color its cell, color one of its cell, and whenever you completely color a cell, a particular cell, or a particular when you completely color a column or completely color a row, you get 1 point for it. So our task in this question is to find out the minimum number of operations or minimum number of cell to color to get at least k points. Okay. So now let's look into few important things in this question. So we know that n is less than equal to 1000. N is bounded by 1000. K is bounded by 100, and even the dimensions ai and bi are bounded by 100. Okay. So so one of the first things that come to our mind when the constraints are small is thinking dynamic programming. And yeah, this is a dynamic programming question because in every point we have choice key, which we sort of have a choice and we have to optimize something. And whenever we come across something like a choice and optimizing something, it's very likely that we have to use dynamic programming, and also the constraints were small. Okay. So how do we go about it? So we know that ai and so if we are given a given rectangle ai and bi, what is the maximum score that we can achieve from what is the maximum score that we can get from this rectangle? This is the maximum score that we can get is 200 from a given rectangle. Okay. And 200 from a given rectangle. Okay. And we have 1000 rectangles. So we'll use dynamic programming in the following manner. So initially, for every rectangle, every rectangle ith rectangle, we'll compute the following thing. Cost of I comma x is essentially the cost of I comma x will basically tell us ki how much, what is the minimum cost required or minimum operations required to get x points from ith rectangle. Okay. So for example, let us consider the 6 3 rectangle. So in this 6 3 rectangle, so the maximum point we can get are maximum points we can get are 9. So 0 1, okay, 0 1 2 3 4 5 6 7 8 9. Okay. So now to get 0 point, we don't need to spend any budget. To get 1 point, we can color three cells. To get 2 points, we can color 6 cells. To get 3 points, we can color 3 cells. To get 4 points, we can color 12 cells. But to get 5 points, we can just color 14 cells. How do we do it? So suppose this is the 6 x 3 rectangle. So to get 3 points, we'll color them to get 1 point you will color 3, 2 point this, 3 point this, 4 point this, and to get 5 point, instead of coloring this row we'll color this two cells. Okay, so the what is happening over here is essentially when you color one entire column, the color if we color a column of this 6 comma 3, it essentially turns into a 5 comma 3 rectangle. So whenever you are reaching something like in this case, whenever you are reaching something like 3 comma 3 and you color one column by 3, so it becomes a 2 comma 3 rectangle, and the efficient way is to color two cells. So using this, so for to get 6 we'll need to color 16 cells. To get 7 points we'll need 17 cells. To get 18 and 19 point, for both of them I will need a whole 18 cells, because by coloring the last rectangle you get 2 points. Okay, so now we compute this array. We compute this array 2D array cost of I comma x, and the size of this array is at most n into ai plus bi, which is 1000 into 200, that is 2 into 10 raised to 5. This is the maximum size of this array. Okay, now we have this cost computed. What now we'll go and compute our final dp. So dp of I, so what we do, so our dp will have two dimensions, I and j, which tells us कि considering first I rectangles, what is minimum cost to get a j score as j. Okay, this is what we'll compute. And how do we compute this? So clearly, if I is equal to 0 and j equals to 0, if both are 0, then dp of ij is equal to 0. Basically, by looking at no, we say that by looking at no, so the dimension of this dp table will be n plus 1 into k plus 1. Okay, so when I say I equal to 0 and j equal to 0, it means by seeing nothing at all, can I have 0 score? Yes. But other than that, if I is equal to 0 and j is greater than equal to 1, all this case dp of I comma j will be minus 1. This is basically asking the case that without seeing anything, without seeing any rectangles, can I get a score? This is not possible. The other way around, when I is greater than equal to 1 and j is equal to 0, in this case dp of ij will be 0 again. That is, can I get zero score by seeing some many rectangles? Always possible. We just don't do anything and we get the required score. Now the important case is the recursive case. Now how do we do about this recursive case? So let us assume while calculating dp of I, while calculating that array dp of I, let us assume that everything before every entry till dp of I minus 1, from dp of 0 to dp of I minus 1 is calculated. Let us assume that. So we can write dp of I comma j as minimum of minimum over uh, dp of I minus 1. So assume that a current rectangle has assume that ith rectangle we can get only mp many let us assume we can only get mp many points from the ith rectangle. So uh, so what is the dp of ij is essentially minimum over all cost of ith rectangle, or if we are one indexing this, so cost of I minus 1, basically cost of ith rectangle, cost of this rectangle, uh, and some k plus dp of I minus 1 comma uh, j minus k. So and we do this over all i's, and we do this over all k, We do this all k from capital J to from 1 to all capital J. Uh, let me we do this from we actually do this from 0, from k from all 0 to j, minimum of j and minimum of j and mp. So what does this mean? So we calculate this minimum over this duration. But what does this recursion essentially means? This recursion means, so suppose this is dp of 0, dp of 1, the array of dp of 1, and dp of I minus 1. Okay, and while calculating dp of I, we say that if we want if we want j, when we calculate dp of ij, I comma j, we say that to get j, we can take k many points from this, we can take k many points from this current rectangle, and the rest many points from the previous I minus 1. Okay, so we take k points from current rectangle, k from ith rectangle, and j minus k many points from previous I minus 1 rectangle, previous rectangles. And since we are taking minimum over all this since we are taking minimum over all the possible we are taking minimum over all possible values, so we'll get absolute minimum, and then we return dp of n comma m. Then we report dp of m n comma like essentially the final number, whatever that is. Dp of n comma k, we'll return this as our answer. Okay, and now the question is, all you need to do is handle this part smartly, that what you do with the minus 1. So essentially this value you just need to handle smartly. Rest all is similar. Now the cool thing about this dynamic programming approach is I used a similar dynamic programming approach in one of the research papers that I have written myself. And yeah, as promised, the shout out for previous content. So one good thing that I noticed is that a lot of you people have actually started giving contests, which is a good thing in itself. That at least that is first step towards consistency. And according to the standings that I have, so we have Ruchit Jagotara, who performed better than me, along with Mrigang Shekhar Shandelia. These two perform better than me. And we also have Devansh Singh Chandil, uh, and Venom 30, and Venom 30 is Vishal Soni. These four people are like top according to my friends rank list. Yeah, so congratulations to shout out to all of them to do a good job. Keep programming, keep being consistent with your programming. And yeah, I also like that other people also gave contest today. So yeah, good job.